Hi everyone, this is a short video summarizing what we talked about in the last class about solving literal equations. What we talked about in that class was that there were two really very basic fundamental steps. Now there are others that include combining like terms and simplifying as much as possible before we get started, but these two steps are the most important ones. First, we need to get the term or terms that contain the variables that we are solving for alone on one side of the equation, and that means all other terms are put on the other side of the equation. This step requires using addition and subtraction. The second step, once we have that variable term on the one side of the equation, we then solve for the variable that we want. And for that, we use multiplication or division. So this is very similar to the process that we used for solving equations and solving inequalities, but now we're solving for specific variables. Okay, so let's take a look at some examples to kind of clarify what we mean here. For example, here's the equation for the circumference of a circle. So circles, the outside of the circle is called the circumference. The line that crosses through the center of the circle that goes from one side to the other is called the diameter. So the circumference is equal to pi times the diameter. And suppose I wanted to solve for pi. In other words, I wonder what pi is really equal to, right? So since this is pi times d, and this term is alone on one side of the equation, the term that has pi in it there's no other term that has pi in it, I know I'm ready to actually solve and go to the second step. And that would be by dividing. If I divide one side by d, I got to divide the other side by d. And when I do that, that cancels out and becomes 1. And we get pi is equal to the circumference divided by the diameter. And actually, that is the definition of pi. It is a ratio of circumference to diameter. And when you pick any circle of any circumference and you divide it by the diameter of that circle, you will get 3.14 going on forever and ever and ever. So we did this in one step. We canceled out the d, and then here is our answer. Pi is equal to the circumference divided by d, or c divided by d. All right, so this is considered like a one-step, very simple formula to solve. Now, suppose I want to solve for, this is a little bit more involved. Suppose I want to solve for y. That means I need to get this term that has the y in it by itself. That means I want to get rid of ax. So because see, before I can do anything, I need to move some stuff. So I can get rid of ax by subtracting ax from both sides of the equation. So now we get by is equal to c minus ax. Now I have the term with my variable alone on one side of the equation. What I do now, then, is get rid of this b, and we would get rid of the b by doing division. So we have a couple of choices here. We can either do this, in other words, we divide everything on the other side by b. So one possible solution is y is equal to c over b minus ax over b. That's one possible solution. The other possible solution is instead of dividing each individual term on the other side by b, we instead divide the whole thing by b. So another possible way to write this solution is c minus ax all over b. Either one of these is correct. So this is good and that's good, right? But what we do to one side, right, we have to do the same thing to the other. Okay? Now, sometimes it can get a little bit more complicated because now we got to deal with maybe the distributive property. So suppose we wanted to, let's solve for d. In other words, we want to get d by itself. This whole term is a term that contains d. So we need to get this whole term alone. So to do that, we've got to get rid of this a. So we're going to subtract a from both sides. So s minus a is equal to n minus 1 times d. Now, it's really tempting maybe to do the distributive property here. If we do that, we get dn minus d. And that's a little bit of a problem because I now have d in two different terms. And that's not going to be easy to solve for. We don't want the variable to be into two different terms because these aren't like terms. I can't just add these together. So the truth is, I really don't want to do that. I don't want to do the distributive property. But if we think about this, this is n minus 1 times d. How could I undo multiplying? We would undo it by dividing. And I'm going to divide by n minus 1. n minus 1 divided by n minus 1 is 1. So I'm going to divide the other side by n minus 1. So d is equal to s minus a over n minus 1. And notice, right, d is outside the parentheses. So since the variable is outside the parentheses, we don't need to do the distributive property. We probably don't want to do the distributive property. Okay? But what happens if, looking at the same equation, I say we want to solve for n, and here n is actually inside the parentheses. We don't like that so much, right? Now we definitely do want to do the distributive property. So s is equal to a plus dn minus d. I multiplied d times n, I multiplied d times 1. This is what I got. So now I have a term that has n in it, right? That's the term that I'm solving for. That's the variable I'm solving for. So we got to get rid of the a, and we got to get rid of this negative d. So how would we get rid of the a? We could subtract a from both sides, and we could add d to both sides. If I do that, I got to subtract a and add d over here. So s minus a plus d is equal to dn. Now we have our variable alone. Now we get our term alone. We need to get our variable alone. So we need to solve for n. So we have some choices here. We can divide this side by d. We can divide everything over here by d. And if we do that, we get, I'm running out of space here, we get s over d minus a over d. And what's d divided by d? That's 1. So this is one of our answers, s over d minus a over d plus 1. That's a possible solution to this problem. Another solution to this problem, or another way to represent the solution, is that instead of dividing every term by d, we instead divide the whole side by d. And if we do that, we get s minus a plus d over d is equal to n. And this is correct, and this is correct. Either one is fine. In either case, the d's have canceled out. We have n by itself. You can either divide everything by d, or we can divide the entire side by d. it really is equivalent. So we have some options there as well, just like before. The last example that we're going to look at, the last couple of examples, are going to involve a little bit more complicated process. We talked about a problem like this the other day, and if we want to suppose we want to solve for x. Suppose we want to solve for x. That means we need to get this x by itself, but we got all of this other stuff that's hanging out with it. One way to deal with the problem, we talked about in class the other day, is multiply both sides by s. The reason why, this s and this s cancel each other out. We get sz is equal to x minus x bar. And then our next step would be to add x bar to both sides, and we get sz plus x bar is equal to x. So that's one possible way to solve this problem. A second possible way to solve the problem is to put z over 1. And if we put z over 1, we can cross multiply. So if I cross multiply here, I get, let me use a different color here, I get x minus x bar. If I cross multiply here, we get s times z. Notice that this equation here and this equation here are exactly the same. Then the last step for this would be to add x bar to both sides, and we get x is equal to sz plus x bar, which is the same as this answer here, exactly the same. Okay? So this equation can be solved two different ways. Essentially, though, we end up with the same equation and we end up with the same solution. I'm trying to think if there's another way that we could solve this. I don't think that there is. I think we're all set. I think these are the two ways. So that's it. So last but not least, what happens if we need to solve for a variable that's actually a part of two different terms? Well, the same idea applies. Any term that has the variable that we're looking for needs to be on one side of the equation, and both this term and this term are on the same side of the equation. Any term that doesn't have a p needs to be on the other side, and that's where a is. Now the problem is I can't add these together because they're not like terms. So what I need to do is actually the distributive property. I need to pull that p away from both of these terms. And this is called factoring, but it really is the distributive property. This is what would happen if I took p away from here and from here. Because if I think about multiplying, p times 1, that's p. p times rt, that's prt. So I pull whatever this variable is that they have in common, I pull it out front, and then I think, what could I multiply that by to get back to the original expression, right? So then now, since I'm trying to solve for p, I would divide both sides by 1 plus rt, because this is going to cancel out. But I got to do that to the other side too, 1 plus rt. So our answer is a over 1 plus rt is equal to p. So sometimes you have to factor out the variable using the distributive property. All right, that's it. That's the video. Some of this material was not covered in class on Monday, but it will be covered in class tomorrow. See you then.